Hey YouTube, welcome back. Today we have this problem. It's called the unique number of occurrence. Given an array of integers called array, we want to return true if the number of occurrence of each value is the array in the array is unique or false otherwise. We have here input array, which is this numbers. We have 3 ones, 2 twos, and 1 threes, and which it's true because the value of 1 has 3 occurrences, or like how to pronounce occurrences. Let's just double check my pronunciation. Occurrences. Okay, not occurrence. Occurrences. Okay, so the value 1 has 3 occurrences. Value 2 has 2 occurrences, and 3 has 1. No two values have the same number of occurrences at all. And this one, it's false because 1 have 1 occurrences and 2 has 1 occurrence. So that means they have the same occurrence, so it's false. And here it's true because minus 3 has 3 occurrences. Number 0 has 2, 1 has 4, and 10 has 1. So yeah, there is no duplication in occurrences. There's 2 ways to solve this problem. One using a hash map, and the other one is to just count, just counting sort, and counting sort. And today I will go with the first one. I guess both of them share a lot of similarities. So yeah, if you watch the first, you'll understand the second, stuff like that. So for this one, I want to create an array. Okay, like let me just have this. Okay, I want to create an array. And in this array, I will sort, let's say that has number like 1, 2, 3, okay, and 2 again, and 4, and 1. For example, let's say we have this array. So what I want to do, I want to just store the frequency, the occurrences of each number. So this number 1 is appeared as 2 times, number 2 has appeared as 2 times, number 3 is 1 time, and number 4 is 1 time. And I will search through this array through a specific number. So each, like if I expect that all occurrences should be unique, so I expect that each number here has it does not equals any numbers of the of the array, any numbers other than itself. If that was the case, I will return true. Otherwise, as here, I will return false. Okay. So yeah, let me try. Okay, so first I want to create a frequency array. So it will be const called frequency array, which will equals new array. New array, and it will be equals of length the array, and I will fill it dot fill 0. Okay, so however, if I just make it equals array.length, I could make it array.length, but this one will be not that easy to add because I want to add based on values. So I want to add based on values, and they said that here the numbers are the number length are 1000, and the number of I here, as you can see, the number of I here is bigger than minus 1000, and bigger and also less than 1000. So if I just fill this one with 1000, and I will say why. If I just fill it with 1000, and I will try to, instead of storing, instead of find, I have here 1. So if I have array with 1000, I will make sure that 1 always has the second index. also, if you can see here, the we have minus 1000, so it should have be 2000. The array could have like go from down to up. The array length have, it's not more than 1000 element. However, the range is 2000. The range of each element is 2000. So let's create a constant. Let's call it k, and it will be 1000 because this is what we can see. And what I'm thinking about is just that because the range is 2000, so 2 multiplied by k plus 1, and this is where the this is the most complicated part, and maybe a lot of people does not understand this one, and it's reasonable not to understand. So basically, we wanna accommodating positive and negative numbers. The variable k is defined here as a constant k equals 1000. And in this context, k serves as a constant to make elements non-negative. How? By choosing k as 1000, the code ensures that even if there are negative numbers in the input array, in this input array, okay, they can be adjusted to fit within the range of the array indices. So let's just take an example. So the array index mapping, let's just try to create an example for array index mapping. So the frequency array, this array is used to count the occurrences of elements in the array. To map elements from R to indices in the frequency array, the code uses something we called okay, so I have to add this the second line of code, so you will try to understand this one. So I created the array and I want to count the indices. So I have 4 const num of R. We will create the frequency. We will add like the frequency of the index num plus ke plus. Oh no. Yeah. So let's just try to go back. So here right now. Let's go back because this part needs a lot of description. So right now, the k variable defined a constant, and it has 1000 because there's no number is that the array length is not bigger than 1000. Okay, and I'm just putting it twice because the range of the each element it's 2000 because it's less than. It's bigger than minus 1000, and it's less than 1000. So here in this context, k serves as a context to make elements non-negative by sorry, I'm just losing my shit here because it takes time to try to to describe this one, and also it will be quite easy when we take an example, so just be aware with me. So the key variable, it defines here the constant equals 1000. The key serves as a constant to make elements non-negative by choosing k equals 1000. So the code ensures that even if there are negative numbers in the input array, okay, they can be adjusted to fit within the range indices. This one, okay. So we have array index mapping. So let's just talk about this one. So the frequency array is used to count the occurrences of elements in the array to map elements from R to indices in the frequency array. The code uses num plus k as the index, and let's just say why. Like for positive numbers, let's say that we have num for positive numbers, num plus k allows them to be mapped to indices greater than or equal to 0. So let's just take an example. So let's say num is equal num is equal 5. Oh, okay, num equals 5. Okay, so it will be the index of number 5 in the frequency. It will be 5 plus 1000, which will be 1005, and we will add the index 1005. We add plus 1, so number 5 is represented by the index 1005. However, let's say that the number is minus 5. Okay, so we will just do the same. Minus 5 and 1000, it will be 9095. So minus 5 will be represented by the index 995. So in this example, we'll make sure that all negative positive values are being represented. And maybe I'll take an example here. And after that, we want to sort the array. Sort, it will make it easier for us. So it will be A and B and A minus B. And and also I want a loop. So let's make a loop, and in this one it will be the easiest one. Let I equals 0, I less than frequency dot length, and I plus plus, and yeah, that's it. And I will say if the frequency of I and if the frequency of I, if we have a frequency of I, okay, and the frequency of I again equals the frequency of I plus 1, that means it's not unique, so return false. Otherwise we return true. Maybe it's not easy to understand this one. Why this if statement? Why? Let's just run the code. Yeah, it's working. The cases. Let's just submit it again. Let's see. Yeah, it's working. Okay, so let's just try to describe the code again. So first of all, we have the function unique occurrences takes an array input, and it returns a Boolean value indicating whether the occurrences of the element in the array are unique. It defines a constant called k with the value was 1000 to make sure that elements are non-negative are being represented. And it initialize a frequency array which will have this value, which is the range of the numbers, to be honest. Not to be honest, to be more specific, with all elements initialized to 0. This array will be used to store the frequency occurrences of each element in the array. The code then iterates. Through the input array, okay, incrementing the corresponding element in the frequency array for each element in the array, and it uses N+K as the index to account for non-negative values. And this sorting, which gives us the way to do this if statement. So just beware with me. So after calculating the frequency of occurrences, it sorts the frequency array in ascending order. Sorting it is very necessary for comparing adjusted frequency. So let's say that we have, for example, we have the array of the occurrences, and it just like we have 2 and 4 and 6 and 2 again, and 1 and 3 and 4, for example. So when you try to store it, it will be 1 and 2 and 2 and 4 and 5 and 6. So we don't have to compare each number with the all numbers to make sure that it doesn't equal all of them anymore. We have to just to compare each number with its next. We have to compare each number with its next. Okay, so after calculating the frequency, we sort the frequency array as ascending in ascending order, and the sorting is really necessary for comparing adjusted frequency counts. It then checks if adjusting elements in the sorted frequency array are equals. If they are, it means that they are duplicate frequency, and duplicate frequency counts, and the function returns false. If the loop completes without finding any duplicate frequency counts, it implements that all frequency counts are unique, and the function returns true. So yeah, that's it. This situation, this one could be quite not the easiest one to understand. So if you just found it quite difficult, it was just give yourself a time. It's just worth mentioning, and it worth knowing. So yeah, that's it for this video, and I hope you like my content. So yeah, that's it, and see you in future problems.